So today we will discuss how to solve the given training set using decision tree algorithm. In previous video we have discussed the calculation which is involved in decision tree algorithm, how to find the information gain and how to find the gain of the entropy of each and every samples which is given in the data set. And here we are going to solve this problem using decision tree algorithm. So we have three attributes A1, A2 and A3, and finally we have one outcome is nothing but a classification. Here we have two values for the classification, yes and no, and for A1 attribute we have two values, true and false, and for A2 hot and cool, and for A3 we have high and normal. So first we will find the values of S, the whole sample. What are the different outcomes we have? Yes and no. First we have to check how many yes and how many no are there. So for S, 1, 2, 3, 4, 5, 6. So we have 6 positive S, that is positively contributing for the classification, and no is 1, 2, 3 and 4. We have 4 negative. So first we have to find the entropy of S. Right, we have 6 positive and 4 negative in the outcome. This is entropy of the whole sample. Hence, we are considering only the output values. So now we will be applying it in the formula. We have 6 positive and 4 negative. So 6 out of 10. Totally we have 10 samples. Out of that, 6 samples are positively contributing. We will give the log base to 6 by 10 and minus, and 4 values here out of 10, it is negatively contributing. So 4 divided by 10. So when I calculate, the value is 0.97 and 0.9. So this is entropy of S. This remains same for overall the whole sample till end of the iteration. So I will be writing over here. So entropy of S, what is the value? 0.9709. So the next step is we have to find which attribute is having higher information gain so that I can draw the decision tree. So the decision tree, first we have to find which is the root node, which is the attribute that you have to place in the root node. For that we need the information gain. Which attribute is having the higher information among all the attributes, that should be placed as a tree. The root node in the tree. So first we have 3 attributes A1, A2 and A3. We have to check which attribute is going to get placed as a root node in the tree. So for that you have to find the information gain of A1 and then information gain of A2 and then information gain of A3, and you have to compare this. Which value is highest, that should be placed in the root node of the tree. So first we will check with the attribute A1. So what are the values of A1 we have here in the table? We have 2 values, true and false. So we have true and false as values of A1. So in this we have to check each and every attribute values entropy. So here we will go with S true with respect to A1 attribute. So you have to check all the true values. So we have 1, 2, 3, 4, 5. So we have 5 true values in A1. So among this, which are contributing positive for the in the outcome, and which are all the true values that are contribute negative to the outcome, that should be classified. So here it is true, right? So for this true we have no, it is negative, and for this true we have negative, and what are the other true values? We have 6th sample, right? So this is also negative, and for this true we have negative, and for this true we have positive. So we have 4 negative and 1 positive in true samples with respect to A1. So that is nothing but 1 positive and 4 negative values. So this is how I can consolidate here. I have to find the entropy of the true values. So let me find entropy of yes true. So I will apply the formula over here. So minus 1 by, what is the total value? We have 5, right? 5 true values. Out of 5 true values, 1 is contributing positive. So log base 2 1 by 5 and minus this is 4 out of 5 is contributing negative. So log base 2 4 by 5. So when you calculate this, we have the final result as 0.7219. So entropy of S2 is nothing but 0.7219. So similarly, you have to find the entropy for S false. So S false. What are the false value we have? I mean, how many false values we have here in A1? This is for A1 you are calculating. So for A1 false value 1, 2, 3, 4, 5. So we have 5 false values. Out of this, how many positive and how many negative contributions are there? That we have to take into consideration. So the first false we have positive. In the second false we have positive. And third false we have positive. In fourth false we have positive, and fifth false we have positive. So all 5 samples are positive samples. So we have 5 positive and 0 negative. So as we already discussed in the previous example, how to consolidate this data. If we have only one positive contribution or if you have only the negative contribution in the entropy, obviously the value will be 0.0. No need to calculate the values. So now we have identified what is the entropy of S true and S false in A1. Now we have to find gain of A1 with respect to the sample. Now we will apply the formula. The formula here is you have to find entropy of the whole sample, and then that should be applied with each and every attribute, right? So here we have true and false. So this with respect to each and every attribute entropy of SP. So what is the entropy of S we have here? We have identified the entropy of S 0.9701. So 0.9709 minus, and what are the other values we have here? So how many values we have? 5 divided by 10. We have 10 samples totally. Among that, 5 are positively contributing, right? So 5, and what is the entropy of S true? Minus 5 divided by 10, that is negatively contributing, for entropy SF. So now calculating this 0.9 minus 5 divided by 10 into what is the entropy of ST? We have calculated entropy of ST here. It is 0.7219. We'll apply it over here, and here 5 divided by 10 into what is the entropy of SF? That is calculated over here. It is 0.0. So what will be the final answer for this? It is 0.609. So now the gain which we have identified S comma A1 is nothing but 0.6099. This is the information gain that have been retrieved from A1. So similarly, we have to find for all the attributes. We have to find the information gain for all the attributes so that we can consolidate and find which is having the higher information gain. So already we have written entropy of S value, so we can erase it. So now we will go with respect to A2. So A2, what are the different values we have? The values of A2 is hot and cool. So let us check with entropy of S hot, right? So how many positive and negative values are here? How many hot are there? 1, 2, 3, 4 and 5. So 5 hot, and what are the negative we have? 1, 2, 3, 4, 5. 5 cool values, right? 5 hot and 5 cool values are there. So first we have to identify with the hot value. So how many hot are there? We have 5. Among that, 2 are positive and 3 are negative. See? For hot it is negative, and here it is negative, and for this hot it is positive, and for this hot it is negative, and for this hot it is positive. So we have 2 positive and 3 negative. 2 positive and 3 negative. That's what I have written over here. So if I want to find the entropy of this, you have to apply in the formula 2 out of 5 log base 2 divided by 5 minus, and 3 out of 5 log base 3 by 5. So if I calculate this, what will be the value? 0.9709. So similarly, you have to find the entropy of a school. So how many positive and how many negative values are there in the school? So let us check that. So for this school, I have positive. Here it is positive, and for this school it is negative, and for this school is it positive, and it is positive. So I have 4 positive and 1 negative. So if I apply this in the formula, I will find 4 divided by the total attribute is 5 log base 2, 4 by 5 minus 1 divided by 5 log base 2, 1 divided by 5. So if I solve this, I will find the value as 0.7219. Now find gain of S comma A2. You have to find information gain of A2. So gain of S comma A2. Sample with respect to A2. And we have to find entropy of S. Already we have entropy of S. The whole sample entropy is 0.9709. Right? So minus, how I can apply the formula? I will having 5 out of 10 sample as hot into what is the entropy of hot? 0.9709. Minus, how many cool are there? It is 5 out of 10 into what is the cool entropy? We found it as 0.7219. So if I solve this, obviously I will be getting the value of 0.1245. So the gain of S comma A2 is nothing but 0.1245. So this is gain of A2. Similarly, you have to find gain for A3. So how many attributes you have in the sample? For all those attributes, you have to find the information gain so that we can decide which should be placed in the root node of the decision tree. Which is having the higher information gain, that should be placed as the root node. Now we have another attribute here, it is A3. We will find the gain of A3. So for that, we have entropy of the whole sample. First we have to find the entropy of each and every values of it. So value of A3, right? A3. What are the values we have for A3? So values of A3. So we have high and normal. We have high and normal. These two are values. So let us find entropy of the high. So how many values we have in high? 1, 2, 3, 4, 5, 6. Totally we have 6 values. After that we have to find how many are positively contributing and negatively contributing. Here it is negative, negative, and this is positive. And for this high it is negative, and for this high it is negative, and for high it is positive. So how many positive values we have? 1, 2. So 2 positive and negative 1, 2, 3, 4. We have 4 negative values. So let us find the entropy by applying it to the formula. Minus 2 out of 6 contributing positively, log base 2 divided by 6 minus, and 4 are negatively contributing, divided by 6, log base 4 divided by 6. So what will be the final outcome of this? 0.9183 is the final value. Similarly, you have to find the entropy for the other value of this attribute, that is nothing but the normal. So how many normal we have? 1, 2, 3, 4. We have 4 normal. Among that we have to find which are positively contributing and which are negatively contributing. So for this normal we have positive, and here it is positive, positive, and here it is positive. All normal contributes to positive. So 1, 2, 3, 4. We have 4 positive and 0 negative. So obviously if any one value is 0, then obviously you will be getting the value of 0.0. Now find gain of S comma A3. So you have to apply the whole entropy of S value, right? The whole sample minus So how many values that I can be placing here? It is 6 divided by 10, right? Out of 10 we have 6 values here. So into the high value. What is the entropy of high here? 0.9183. So how many high value you have? 1, 2, 3, 4, 5, 6. That's why I have written 6 out of 10 and the entropy of that hot value. And minus, and how many normal? 1, 2, 3 and 4. So 4 normal out of 10 into, what is the normal entropy value? It is 0.0. So what is the final outcome of this if I calculate this? 0.4199. So the gain of S comma A3 is nothing but 0.4199. So first compare these 3 values. So which one is higher? That should be placed in the root node, right? So how can I place it? So gain of A1 is 0.6, gain of A2 is 0.12 and gain of A3 is 0.41. So while I compare the 0.6 wins the race, so obviously A1 will be placed in the root node because it is having the higher information gain. So it has how many values A1 is having? It is true and false in the table, right? A1 is having only true and false. So I have true here and false here. 2 values, so 2 branches are there for A1. Next you have to find which is the, whether it is possible for you to consolidate and write the label over in the classification here in this leaf node itself, or it is moving for the next iteration. So how many samples are there contributing to true? 1 for A1, right? We are writing for A1. So 1, 2 and then 6. And what are the other values? 7, 8. 7 and 8. Right? Now what are the false values we have? Sample 4 and sample 5. And here 9 and 10. 4, 5, 9 and 10 are contributing to the false. So here 3 is also false. So 1, 2, 6, 7, 8 are contributing to true. 3, 4, 5, 9, 10 are contributing to the false. So let us check whether we can directly move with the classification labels here in the outcome directly. So here if I see true values, 1 is true, it is false, and true, it is false. For 6th true, it is false. And 7th true, it is false, right? If 8 is also false, then obviously we will classify it as with no. So finally we have 8, here it is positive. 1 is false, I mean 1 is yes, the outcome, all other are no. So we cannot classify it here, we have to move further iteration and then check which node should be placed here, which attribute should be placed in this row. And we will check whether we can classify it over here. 3 false, right? It is yes. And 4 false, it is yes, and then 5, it is yes, and then 9th sample false, it is yes, and 10th sample, it is yes. So here we can classify because all the samples are contributing to plus. So we can directly classify it as plus. So now which attribute can I proceed here? I cannot proceed here because I have 2 other attributes, A2 and A3. So I should again find the information gain of this and I have to check which attribute I have to place it over here. So for that I have to take only the samples into consideration 1, 2, 6, 7 and 8 and I can proceed it. So A2, A3 and the outcome. So what it is for A2 you have to take only the samples of 1, 2, 6, 7 and 8. All others we can ignore it. So while I consolidate that and write it hot, it is cool and it is hot and it is hot, right? And here it is high and this is also high and this is high, this is high and this is normal. And in outcome we have no, for this no, no and yes. So what are the samples we have taken into consideration? 1, 2, 6, 7 and 8 alone we have taken into consideration. And from this you have to find the entropy of S. So now if I calculate entropy, so entropy of A2, right? You have to find for A2. For the whole sample, we have 1 positive and 4 negative. So 1 positive and 4 negative. So if I apply this 1 by 5 log base to 1 by 5 minus 4 by 5 log base to 4 by 5. So here I can get the value of 219. So this is the whole entropy value, entropy of S. So now I can update this value because this is no more required. So I will keep track of the current iteration value. So here the entropy of S is 0.7219. So how many values you have in A2? Hot and cool. We have to calculate the entropy of hot. Right? Yes, hot. So check how many values are positive in hot. So we have hot here as no, no, yes, and then here it is no, yes. So we have 1 positive and 3 negative. So we should not consider this, we have to consider only this table. So it is quite confusing, we will erase this so that it is easy for us, right? So for S hot, we have here the hot values 1, 2, 3 and 4. For this we have negative, 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 right? And the last is positive. So we have 3 negative and 1 positive. So if I apply this in the formula, so obviously I will get 1 by 4 log base to 1 by 4 minus 3 by 4 log base to 3 by 4. In this case, we will be getting the value of 8112. Similarly, if you find entropy of S of cool, so for cool, we have only one attribute, right? So that is contributing to the negative. So here we have 0 positive and 1 negative. If this is the case, obviously the value is 0.0. So now find gain of S comma A2. So this is entropy of S. What is the value of entropy of S? 0.7219 minus the whole hot value is 4 out of 5 into what is the entropy of S? It is 0.8112 minus, and the cool value, how many cool values we have? It is 1 out of 5 into what is the entropy of cool? It is 0.8112. So if I calculate this, I will get the value 0.3219. So gain of S comma A2 is nothing but 0.3219. So now we have to find, we have another attribute, it is A3. So for that, what are the values we have? For A3, high and normal. Right? High and normal. We have to find entropy of high. So for high, how many values we have positive and how many negative values we have? For high it is negative, and here it is negative, it is negative and it is negative. All are negative, right? How many negative we have? 1, 2, 3 and 4. So 4 negative and 0 positive, so the entropy value is 0.0. And next the entropy of, what are the other values we have? Normal, S normal, right? So for S normal we have only 1, that is positive. So 1 positive and 0 negative. So the value is 0.0. If I find the gain of the A3, S comma A3 is nothing but 0.7219, that is the whole entropy value, minus 4 divided by 5, because 4 high values, so the high entropy is 0, right? And how many normal value I have? 1 out of 5, and the normal value entropy is 0.0. So if I calculate this, I will be getting value 7219. So the gain of S comma A3 is nothing but 0.7219. So now compare these two values. It is 0.3 and it is 0.7. Obviously A3 wins the race. So you have to place A3 as the next level node. So this is A3. Here it 2. So how many values are there in A3? High and normal. So we have high and normal 2 branches. Right? So what are the values we have for high? 1, 2, 6 and 7. Right? 1, 2, 6 and 7. And for more normal we have 8th sample. So now try to consolidate whether it is giving us the class label. So for 1 it is negative, for 2 it is negative, for 6 it is negative, and for 7 it is negative. So all samples contribute to negative. So it comes to the conclusion. and for 8 we have positive. So here we can label it as positive, right? So this is how a decision tree can be drawn for any given sample.